Today, we're taking a pretty fascinating look right inside the human body. Our goal here? We're going to break down exactly how your body processes the food you eat, how it turns that food into the fuel you absolutely need to survive, and crucially, what actually happens when that incredibly intricate internal system breaks down. We're going to demystify diabetes by looking at the pure mechanical reality of blood sugar. Let's get into it. To kick things off, I really want you to think about this question for a second. How does the food you eat actually power your brain and your muscles? It's something we totally take for granted, but absolutely every single cell in your body requires energy to survive. Whether we're talking about a literal brain cell firing off signals so you can understand what I'm saying right now, or a muscle cell contracting so you can lift a cup of coffee, they all need a constant, reliable source of fuel. Okay, let's dive into this. Here is our roadmap for today. We'll be covering fueling the healthy body, type 1, the missing key, type 2, the blocked lock, spotting the warning signs, and finally, long-term impacts and management. Section 1, fueling the healthy body. So, it all starts with glucose. When you eat carbohydrate-heavy foods, think starchy stuff, sugary treats, milk or fruit, your digestive system immediately breaks them down into nutrient molecules. And the absolute most important of these is glucose, which is a simple sugar. Actually, if you were to taste it, it would literally taste sweet. Once broken down, this glucose gets absorbed through your digestive tract and is carried by your bloodstream to organs all over your body. Now, here's where it gets super interesting. That glucose floating around in your bloodstream, it cannot enter your body's cells completely on its own. It needs some help, and that's exactly where insulin comes in. Insulin is a chemical messenger hormone. As your blood glucose levels rise after a meal, this little gland sitting just underneath your stomach called the pancreas gets to work. Specifically, the beta cells inside the pancreas start producing and releasing this crucial messenger into your bloodstream, right alongside all that glucose. Insulin is a key unlocking the door to the cells. This quote from Diabetes UK is just a brilliant visual metaphor. Imagine the surface of your cells having these little locked doors. These are the insulin receptors. For the glucose to actually be taken up by the cell and used for energy, the insulin molecule has to bind to those receptors. It literally acts as a key, unlocking the channels so the glucose can finally enter the cell. Let's just walk through these steps together so you can see how this builds into a perfectly balanced system. First, you eat carbs. Second, they break down to glucose. Third, that glucose hits your bloodstream. The body detects this sudden rise, and the pancreas releases insulin. That insulin travels to your muscle and brain cells, unlocks the doors. The glucose rushes in to give you that energy, and boom, your blood glucose levels drop right back down to an optimum safe level. It is honestly a beautiful, harmonious cycle. Section 2, Type 1, the missing key. So what happens when it breaks? Well, in type 1 diabetes, the body experiences an autoimmune response for reasons that still aren't entirely clear, though we know genetics play a huge role. The body's own immune system makes a catastrophic mistake. In this tragic biological twist, it attacks and destroys those crucial insulin-producing beta cells in the pancreas. And because those cells are destroyed, absolutely no insulin is produced. None. Going back to our door metaphor, this means the essential keys are entirely missing from the body. Imagine the glucose molecules just piling up in the bloodstream. Without insulin to unlock the door, they are totally trapped. The body has plenty of energy floating around, but the cells? They're essentially starving because their doors remain firmly locked. Because of this, blood sugar levels rise, and they rise dangerously fast. This is exactly why individuals with type 1 are entirely insulin dependent. They absolutely must introduce the keys externally. Section 3, Type 2, the blocked lock. Moving on to type 2 diabetes, the internal problem here isn't a missing key. The pancreas is actually producing enough insulin. The problem is with the locks. Over time, the cells become completely resistant to insulin. They literally start to ignore the messenger. This happens because the receptors on the cell doors become desensitized, or as the research vividly describes it, they become physically furred up with fat deposits. So even though the insulin is right there, desperately trying to do its job, it simply cannot open the cell doors properly. This state is what we call insulin resistance. Now, what's really interesting about this is the sheer scale of type 2. When you hear about diabetes in the general population, type 2 accounts for the vast majority of cases. We're talking between 80 to 90% of all diabetes cases. It is a massive, incredibly common metabolic disorder. So let's contrast these two distinct breakdowns for a second. Type 1 is an autoimmune condition where no insulin is made whatsoever. It typically has very sudden onset, usually found in people under 40 or during childhood. Type 2, on the other hand, is a metabolic condition deeply rooted in insulin resistance. It has a much more gradual onset, usually appearing way after age 40, though to be honest, that age is dropping. And crucially, while type 2 is heavily linked to lifestyle factors like an inactive lifestyle, obesity, and family history, it's super important to note that individuals of a perfectly healthy weight can totally develop it too. Section 4. Spotting the warning signs. Despite their totally different mechanical causes, both type 1 and type 2 actually share an easy-to-read checklist of symptoms. Why? Well, because the end result is exactly the same. Way too much glucose in the blood and starving cells. Because the cells are just desperate for energy, you feel immense tiredness and lethargy. The body might even start frantically breaking down its fat reserves, which leads to unexplained weight loss. At the exact same time, the body's desperately trying to flush out that toxic excess glucose through the kidneys. As the kidneys filter it out, they pull a ton of water with it, causing excessive thirst and frequent urination. That sugary urine then creates a breeding ground for bacteria, leading to things like thrush, genital itching, and slow-healing wounds. The excess glucose can literally even build up in the lens of the eye, causing blurred vision. It's the body sounding the alarm. But here is the major distinction you really need to remember: symptom onset. Because type 1 is the sudden loss of insulin, those severe symptoms generally appear very quickly, often over just a few weeks. Type 2, however, it's insidious. The symptoms come on so gradually that the condition can literally hide silently for up to 10 years before someone realizes they have it. In fact, about 1 in 4 people with type 2 diabetes are completely unaware they even have the disease. Section 5. Long-term impacts and management. And this brilliantly illustrates exactly why managing blood sugar is so vital. High concentrations of sugar in the blood are quite literally toxic. Over a period of months, this rogue sugar damages the small micro blood vessels, which can lead to a loss of sight, kidney disease, and severe nerve damage. Over years and decades, this damage spreads to the larger macro blood vessels, and this is exactly what leads to severe cardiovascular complications like heart disease, strokes, and poor blood circulation. The human body simply cannot handle unregulated sugar. But the good news is there is incredibly effective management for both. For type 1, because the body produces zero insulin, management is immediate. It relies on lifelong insulin injections alongside careful blood sugar monitoring and carbohydrate counting. Type 2 management, however, requires a completely different approach. Because it's metabolic, the first line of defense often involves aggressive lifestyle and diet changes, stuff like a low-carb diet and weight loss, which can actually make the body more sensitized to sugar. Following that, there are highly specific medications designed to help resensitize those stubborn insulin receptors, so they finally start listening to the keys again. So the crucial point here is that type 2 diabetes is a progressive condition. Because the cell doors are resistant and won't open easily, the pancreas goes into total overdrive, just pumping out more and more insulin to try and force the blood sugar down. Eventually, if left unchecked, that overworked pancreas just can't cope anymore, and it wears out. When that happens, a type 2 patient will also require insulin therapy, exactly like a type 1 patient. So we've covered the mechanics of the healthy body, the missing key of type 1, the blocked locks of type 2, and the absolute necessity of keeping this complex biological engine maintained. But I want to leave you with this final provocative thought to reflect on. Knowing how silently and gradually insulin resistance builds up in the background over years, what lifestyle choices are fueling your body's engine today? Thanks so much for joining me on this explainer, and I'll catch you on the next one.